Okay, we're looking at section 10.2, and 10.2 I think can look a little bit intimidating in terms of some of the problems, but I think it's not that bad once you know what's going on with it. I'm going to keep with the same strategy of going right to the tutor mode and then right to solution, and you can kind of see some of the steps that they've done on this example. If you have a fraction raised to a power, okay, and the power itself is a fraction, I realize that that can look a little bit tricky. But what you need to recognize is that when you have a negative power, that's the same as having a positive power on the opposite part of the fraction. So this is how they address things. And this is like back in chapter 5, the beginning of chapter 5, you dealt with negative powers. But they just kind of show initially that this is the same as 1 divided by all of the same stuff raised to the positive 2/3 power. So negatives like this in front of the 125, those don't flip and move, okay, like in terms of accomplishing these types of steps. But it's negative powers that cause you to say, alright, it's the same as being a positive power on the bottom of a fraction. So I guess imagine this whole thing over 1 and that it flipped down and changed the sign of the power. Okay, from here, you'll notice what they'll do is they'll say 2/3 is the same as 1/3 times 2 at the power level. And what they're really saying is, you know, when you take a fractional power, the fraction part is actually the thing that's going to affect what's over here as a radical. So a 1/3 power is the same as a cube root. So when you go from here to here, it kind of looks like a magic step. But what they're doing is saying that you cube root negative 125, you cube root 8, and what do you get? Well, 125 done out as a factor tree is 5 times 5 times 5. So the cube root of 5 cubed is 5, or if it's a negative, negative 5. So that's where that came from. Cube root of 8, 8 is 2 times 2 times 2. Well, there's 2 right there. So the cube root of 2 cubed is 2. Once they get it to this point, I mean, once you get it there, it's not that bad because you can just say, I square the bottom fraction there, which means I square the top and the bottom of that. I get 25 over 4, and then I flip and multiply. I show the step over here. I get 4 over 25 as a final result. So a lot of steps there, but think about basically what's involved is you can flip things around because of the negative power, and then you kind of take care of the cube root, and then you'll take care of the squaring part. That kind of falls out like that. Another example here, this is a little different. They still have the kind of the weird power going on here, but they say enter the solution using rational exponents in the box below. Assume that the variables are positive. So they've given you a couple of pieces of information. If they say enter the solution with rational exponents, it's saying, you know, just leave your answer with the fractional power. You don't have to kind of pull out of the background that it's a cube root or anything like that. They're just kind of saying work with the numbers. And then assume all variables are positive. We don't have to worry about absolute value things popping out. So if you reduce, let's see the tutor mode, they should show it what I'm about to say, but they show reducing the values. Let's see. Alright, so they're kind of showing you, I guess first of all, that you can kind of group these things together. Yeah, I see what they're doing. So they're kind of just saying, if you wanted to, you can put all the regular numbers together as fraction, the 5 on top, the 2 on the bottom. The x's will be on top and bottom, the y's on top and bottom. And then you can reduce in each fraction, and then potentially put it back together at the end. So 5 over 2 stays as 5 over 2. I can subtract the 1 from the 1 power from the 4 power here. I'm going to get a power of 3 for x on top. even with the fractions, even though I know that 2/3 power means squaring y and then cube rooting y, you can subtract 2/3 from 3 like a power, just like this one over here did, and you'd end up with 3 take away 2/3, common denominator, 9/3 over 9/3 minus 2/3 gives you 7/3. Put it all back together, you get 5x to the third, y to the 7 over 3, all divided by 2. So kind of a weird looking answer, but that's the final result of that problem. Okay, here's another weird one, right? Looking at this here, we got to figure out how to proceed. We jump to the tutor mode, solution. Notice what they do here. Because you have some stuff that could be combined together on the inside before you even worry about this power, in this big set of parentheses, they go after some of that and they say, okay, here you go, you've got the 9, and then on top here there's nothing that can be underneath that to reduce with it. But over here you've got x and x to the negative 2. If I want to bring those together, negative 2 is a smaller power, and I could say bring that up to the top as a positive 2. They show it as subtracting a negative 2, which is just the same as plus 2. So when you put it all together, you're going to end up with x cubed on that part. So you see it right there. Y to the negative 2 becomes y to the positive 2 up top, combined with y to the positive 2, you get y to the 4th. So whether you think about it as a double negative or bringing it up as a plus, either way what's on the inside ends up being 9, x to the third, y to the 4th, and then we have on what's on the outside the negative 1/2 power that we still have to deal with. So they show next that you could take each value inside and raise it to the negative 1/2 power. Okay, I would preferably take this whole thing and flip it down below as a positive 1/2 power instead of a negative 1/2 power. But they decide to distribute that in, and then you deal with each case where you say, okay, I've got these values here. I don't like the way they've done this. If you flipped everything down below, you'd be talking about square rooting underneath. So what happens is, let's see, they took the 9 to the negative 1/2, they called it a third, which what happened was they said 1 over the square root of 9, which becomes 1 over 3. So they did that. They multiplied the 3 times negative 1/2 power here, which gives you x to the negative 3 over 2, which flips down bottom as x to the positive 3 over 2. And then y to the negative 2nd, I see, because they took y to the 4th times negative 1/2 powers there. You get a negative 2 power. They flipped it down bottom as a positive 2 power. So everything kind of flips down below, becomes positive powers, and then they calculate it. Okay, we have time for one more example. 27 over 64 to the 2/3 power. Okay, what you could basically say is that it's already a positive power, which is good. From here, I can kind of think about cube rooting both those values because of the 3 on bottom. So they say cube root, you're going to get 3 and 4, because 27 is 3 times 3 times 3, 64 is 4 times 4 times 4. You get those results, you square the fraction after that, you get 9 over 16. So that's what kind of happened there. The 64 part, remember, you can make a factor tree. If you broke it down all the way for 64, you'd end up with actually 2 times 2 times 2 times 2 times 2 times 2. You'd end up with 2 to the 6th. So when you cube root that, you'd end up with 2 squared. But then you'd still get the 4 out of it. So either way, you're going to come up with it. If you make a factor tree, it might help you to see that there's actually 3 4s or 6 2s. same idea. Either way, you'll get a 4 out of it there.